For our ME480 project this semester, we've been commissioned to build a vehicle for the human powered vehicle competition that the school takes part in here coming in the spring. So our goal was to make a regular bicycle meet the competition rules so that we could prove that a regular bicycle is the most efficient means of transportation. Most teams actually build these huge four-wheel, three-wheel vehicles, and they're kind of cumbersome, kind of slow. And for the needs of the competition, they really just don't work out too well. So our main focus was on this roll cage here. This is what makes this bicycle meet the rules of the competition. So the competition rules state that the rider must be harnessed in to the vehicle and must have a roll cage around him to protect from side impacts and top impacts. So as you can see, we've built a roll cage with a nice harness. This is a racing harness, so this is definitely going to meet the specifications that it needs to meet. And we built this around this bicycle. We've built it so that it can be swapped to a different bike frame so that if the user wants to use a different frame, they can. So down here, there's a little 3D printed mounts down there that actually squeeze the frame between two steel plates that hold it on. And we have another mounting point down here. And this mounting point can be adjusted to fit whatever frame necessary. So that's that part of it. And to determine if it'll meet the competition standards, we actually did an FEA study on the frame itself. And this can be seen here. One of the main studies that we had to complete is that when the bike is flipped over with the rider strapped in, the frame cannot deflect more than, I think it was about 5 centimeters. So if you look right here, this is actually our deflection. Right here we've got gravity inverted, so we're pretending that the bike is upside down. And we've got it so there's actually a rider clipped in. We designed the FEA to allow that. Even though a rider is not shown, their weight is still factored into the study along with inverted gravity. And as you can see, the max deflection is 3.2 millimeters. So as you can see, this frame does meet the SME specifications and rules for the human powered vehicle competition. We also did a side load study, which also met the specifications, and we're confident that as they participate in this competition, they should be able to win.